Hi, welcome to the WinDBG examples chapter. We begin with some basic control over WinDBG and also basic control over the target program. The program that we are going to inspect is called infcounter.asm. Let's begin by looking at the source code. This is a pretty simple program. As we can see, it just contains one infinite loop. Before the infinite loop, it contains some initialization to the EAX register. Inside the loop, EAX is transformed in some way. We can see that it is copied into ECX, then ECX is shifted, next EAX is ended to 1, negated, and then ended to this value. Finally, ECX is XORed to EAX, which means that EAX now has a new value. You shouldn't really care about what you see inside this loop. Basically, we just have to understand that this loop is infinite, which means that the program will keep executing those instructions forever, or at least until we stop it. Those instructions will probably never be reached. Let's begin by assembling and then running this program, just to make sure that we understand the effect of the infinite loop. I first save the program, and next I open a console, and I'm going to assemble and run this program. As expected, when I run this program, it just waits forever. That is because it is stuck inside an infinite loop. I pressed Ctrl+C to stop this program, and next I'm exiting the console. Let's open this program with WinDBG. In order to open an executable file, we pick File from the menu and then Open Executable. We could also use the shortcut Ctrl+E. Next, we should find the file that we want to open. We only need the executable file. The debugger doesn't care about the assembly file. We could, for example, only open an executable file even if we don't have the source code. I copy the path of the executable file and I paste it here. Now I click on infinitecounter.exe. As we can see, I got this command line, which is actually infcounter.exe, just paused. It is currently paused, it is not running. We also got the command line of WinDBG, which allows us to enter commands in order to control the program infinitecounter.exe. Maybe the most basic command that you can use inside the debugger is G. G is a shortcut for Go. It changes the state of the program from paused to running. To send this command G to WinDBG, I have to press the return key. I want to note that currently we are at this location, which means that this is the current value of EIP, and it points on this instruction, int3. We could open the disassembly window to see all the instructions around this current instruction, just to understand where we are currently. And this is some unknown place, which probably belongs to the operation system. It is definitely not our code. At this point, if I'm going to send the G command to the debugger will just let the program run. Now I press the return key. I have this message here, busy, and another message, debuggy is running. I remind you that debuggy is just another name for the target program, which means that currently infinite counter.exe is running. Nothing really happens because infinite counter is basically just an infinite loop, which means that this program will really run forever. At this point, the debugger is not responsive. We cannot send any command to the debugger. It waits for the program to return somehow, or maybe to pause somehow. We are really stuck because we know that this program is not going to terminate or to pause. It is an infinite loop. We can't really do anything useful at this point. If this ever happens to you, you could pause the target program, for example using this button, or maybe using the menus. If we click here, the target program will break, and we will gain control over the debugger. We can see that the target program has stopped in some random place, which we don't have much information about. And again, it is also an int3 instruction. We could use the G command again to let the program continue running. And we can also pause the target program again. Basically, we have full control over the state of the target program. We could either let it continue running or pause it. Some other things that we can do through the debug menu. We could, for example, request to restart the target program. There is a shortcut for this because this is a very common operation. Control plus Shift plus F5. Let's restart the debug. We can see that the old program was terminated and a new one was opened. This is basically what restart does. Again, we have control over the debugger. We can use again the G command to let the program run. Now the debugger is running and the debugger is waiting. Another thing that we can do through the debug menu is stop debugging. If for whatever reason you want to stop debugging the program, trying to close it will not always be a good idea because it will not always work. However, you could always use the debug menu to stop debugging, or maybe the shortcut Shift plus F5. I stop debugging. As we can see, the target program is closed, and now WinDBG is empty. I want to demonstrate something else which could be done using WinDBG. You could attach to a running program, which is sometimes a very useful feature. Imagine, for example, that you have a very important piece of code that must be running all the time. Maybe, for example, a web server. And you want to be able to fix some problem without having to restart the server. You could, for example, attach to the server using a debugger, and then later detach. we are going to see an example of attaching to a process. We begin by running the program infinite counter. It is inside an infinite loop, therefore it will never terminate. Let's use WinDBG to attach to this program. In order to do this, we pick from the File menu, Attach to a process. We could also use F6 as a shortcut. In this new window, we are going to find the program infinitecounter.exe. It is here. We choose this program and we press OK. Now the program infinite counter is paused and we can control it using the debugger. We could, for example, use the command which we already know, G, which is going to resume infinite counter, which means that currently infinite counter is running. Using only the G command will not get us so far because it is really crude. We cannot get accurate results with G. Let's stop debugging for the moment and try something else. First break and then stop debugging. Again, we open the same file using open executable. However, this time we are going to add a breakpoint. Using a breakpoint, the program will not just run indefinitely. It will stop at some location that is determined ahead of time. We are going to put a breakpoint on the entry point, which is really the equivalent of the start label, which means that this breakpoint will be over this instruction, which is the first instruction that we wrote, XOR EAX EAX. I press the return key, and now a new breakpoint is set. Now if I use the G command, I expect the target program to resume running, and then whenever it encounters the first instruction, XOR EAX EAX, I expect it to pause and give me back the control. I press the return key, and indeed it seems like the program has paused at the XOR EAX EAX instruction, at this address. Let's see the disassembly window. We can see here the instruction XOR EAX EAX followed by the instruction INC EAX, just like we have seen inside the inf counter source file. Besides using the G command to just let the program resume, we could step. Maybe the easiest way to step is using the GUI commands. For example, we have step into or step over. Using step into, we could step and execute one instruction at a time. The step over command is going to have exactly the same effect here, because we don't have any call instructions. Whenever we click, for example, on step into, we can see in the command line that the T command was executed, which means that the T command does the same thing. It allows us to step into. Step over is done by the P command. I want to emphasize that we can see the contents of all the registers in every step. We can also see the next instruction, which is going to execute, which is pretty useful. Even if we don't have the disassembly window, we can still predict the next instruction, which is going to be executed. If at this point we use the G command, the program is going to resume. And somehow we lose control over the target program, because we cannot really stop at any useful location at this point. If at this point we break, we get to some random location, which is really not useful for us. We could, for example, use the G command again to continue, or maybe break again. But we really lost touch with the code that we wrote. Let's show another way to do it. First, let's restart the debugging. Again, we put breakpoint on the entry. And we use the G command to get to the entry point. Let's try something else at this point. Maybe, for example, we can add another breakpoint at this location, exactly on the jump instruction. We are going to do it using the following command, bp, and then the address. I remind you that this address is in base 16. I press the return key. I can see here marked with red the breakpoint. This time, if I use the G command, the program will not run indefinitely. I expect it to pause at this instruction, at this jump instruction. I press the return key, and I get to the jump instruction. What is going to happen if I send the G command again? Think about it for a few seconds. Let's try. I'm going to press the return key. It seems like we got again to the same instruction, jump. How can it be? Very simple. Basically what has happened is that we moved through all the instructions in one iteration and got to the next iteration. As this is an infinite loop, we got to the same instruction again. If we use the G command again, we will get to the jump instruction again. We could see, for example, that the value of EAX is changed in every iteration. Let's summarize the commands that we have seen for WinDBG. The first and very basic command is G. It allows us to resume the target program. The target program will keep running until something happens. Maybe, for example, it reaches some breakpoint, or maybe we pause it ourselves, and so on. The bp command allows us to put a breakpoint. We will discuss this command in a more detailed fashion later, but for now just know that this command allows us to put a breakpoint. We've also seen the two commands T and also P. T is exactly equivalent to this button, step into, and P is exactly equivalent to this button, step over. This was about basically controlling WinDBG and have basic control over the target program. See you on the next lesson.